Hello students, and welcome to this lesson on graphing the square root function. Our objective today is that we will graph the function f of x is equal to square root x and analyze domain and range using journal notes and practice problems. So we're going to really talk about the square root of x in this lesson. So first off, what I want to do is I want to actually draw the parent function of the square root of x. So to do so, we're going to plug in some values and see what we get. Now, I've drawn this table here, and that's where I'm going to get my values to create my square root function. So we can plug in some values. If I plug in -1 to the square root of x, then we see that we get the square root of -1. And we know that that is I. But I is an imaginary number, and it requires us to do our imaginary axis, and as we see here, we're only using x and y. So we're going to just say that this is undefined. So, undefined. Just going to say undef. All right, then we plug in 0. And the square root of 0 is 0. All right, then we plug in 1. The square root of 1 is 1. Then we start plugging in these other numbers. So we plug in 2. The square root of 2 is... the square root of 2 is square root of 2. It doesn't go any simpler than that. Then we take the square root of 4, and the square root of 4 is actually just 2. And I'm going to jump ahead, and we're just going to use some nice numbers that will give us some nice points. So we see that the square root of 9 is actually 3. So now I have 4 actually really good points that I can graph. I have 1, 0, 4, and 9. All right, so let's go over to our graph. So at 0, 0, we plot our first point. Then we go to 1, 1. Then our next point isn't going to be until 1, 2, 3, 4, and up 2. And then we go all the way to 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, and up 3. All right, and then we get this nice curve here. We connect our points, and bam, our function is graphed. So, what did we notice about the domain and range of this function? Well, the domain has to be x is greater than or equal to 0, because we saw that the function was undefined before then. Likewise, our range in this case is going to be y is greater than or equal to 0, because again, I didn't have any values below 0 because my outputs were all undefined. All right, so our vertex or endpoint in this case is going to be 0, 0. So that's that start point over here. That is right here. It kind of acts as the vertex, but we can't really call it the vertex because it's not really a parabola or anything like that, so we're just going to call it the endpoint. All right, now that we have a good idea of what the square root function looks like, let's go ahead and talk about its inverse. So we've been doing inverses for a little while, and we did the inverse of the quadratic function, and we saw that given certain restrictions, the inverse of the quadratic was the square root. So now we want to do the same thing for square root functions. So I want to introduce a new way to find inverses, and actually I want to introduce two. The first one is that the inverse can be found by reflecting across the function y equals x. So y equals x is this diagonal line here that starts at 0, 0, and then it goes over 1 and up 1 for all of eternity. So if you reflect any function over that line, then it's going to give you the inverse. However, I also wanted to introduce another way to solve for it algebraically. Earlier what we were doing is we were solving for f of x, but what I want to introduce is this. So if I'm starting with this function, f of x is equal to square root x, and I want to find its inverse. What I want to do is I want to change f of x into a y. So this becomes y is equal to square root x. And then I want to solve it for x equals, just like I did before. So I just take the square of both sides, and I get y squared is equal to x and then I do my notation change. So I say f negative 1 of x is equal to x squared. So that's just a different way to think about how to solve for the inverse. In my opinion, it ends up being a little bit cleaner. All right, so let's actually graph the square root of x and its inverse now. All right, so for the square root of x, we determined that the domain was x is greater than or equal to 0, and the range is y is greater than or equal to 0. So let's go ahead and graph it. So we have the point 1, 1, we have the point 0, 0. We have the point 1, 1. Then we go to 1, 2, 3, 4, up 2. And we go over 9. And up 3. So that's my original function here. And then I want to graph f negative 1 of x. Now remember, whenever we're graphing the inverse, or whenever we're finding the inverse, what we're really doing is we're switching the two variables, right? We're switching the inputs and the outputs. So all of my inputs, my domains, are going to switch to outputs, and all of my range is going to switch to inputs. So likewise, our domain and range restrictions are going to swap. So these two are going to swap so that the range restriction of my original function defines the domain restriction, and the domain restriction defines the range restriction. So x is greater than or equal to 0, and y is greater than or equal to 0. And my function, like I found down here, is going to be f negative 1 of x is equal to x squared. So it's a quadratic function that has these restraints. So it's a quadratic function that has to be greater than x equals 0, greater than or equal to x equals 0, and it has to have the y values have to be positive as well. So this restricts us to be only within the first quadrant. So let's start graphing some points. So when I input 0, let's do 0, 1, 2, and 3. When I input 0 into x squared, I get 0. When I input 1, I get 1. When I input 2, I get 4. And when I get input 3, I get 9. So this is going to be 0, 0, 1, 1, 2, 4, 1, 2, 3, 4. And it's going to be 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I connect these points, and that is your inverse function of the function f of x. So this is f of x, and this is f inverse of x. And what we note is that the domain and range restrictions swapped. All right, cool. Now we're going to shift gears a little bit, and we're going to focus on graphing f of x using its attributes. So take a moment to go ahead and draw these tables, and we're going to talk about how shifting our graph is going to affect our function here. So for this first one, we're going to do a +1. Now you did your warm-up and you know your transformation tables, so you know that if you have something in this position, it's going to shift it up. And remember, we have our transformation form. So we have f of x is equal to plus or minus a. Now it's going to be a square root function. So it's a square root of x minus h plus k. So if we have something in the k position, k moves up and down, and that's going to remain the same here. So we have our original function, which I'll graph here in blue. We have 1, 1, or 0, 0, 1, 1, 4, 2, and 9, 9, 3. And we see that those points are there, and then I want to shift them up 1. So each of those points just gets shifted up 1. and my new function is here. Now my domain and range have changed. So my domain, well, in this case, my domain is going to stay the same. X is still greater than or equal to 0, but now my range is going to be y is greater than or equal to 1. So we see how k influences the range. All right, and then we see the same thing here, k going down. We go down 2, so all of my points, right, my blue points are going to shift down 2 places. To these red points. So down 2, here, down 2, and then here, down 2. All right, and we connect our function. And there we go. It's a nice gentle curve here. All right, and you see how it's not exactly a straight line. It is a curve. So make sure that your graph is curved here. So now my range is going to be y is greater than or equal to -2. Domain is still x is greater than or equal to 0. And we're going to go through and do this for the next few functions. So now we're moving our h. H moves forward and backward. So we're going to go ahead and graph our transformation if h is going to be a positive number or we have -2 in here. So we shifted all of our points over 2, and you get y is greater than or equal to. Now my range hasn't changed, but my domain is now going to be x is greater than or equal to 2. So we see how change in h is actually going to influence our domain. And our restriction here in h is actually just, or sorry, our restriction here in our domain is actually just the number that is h. All right, and the same thing will happen for a positive shift, except now we're going to move to the left. And again, for this function, it was x plus 3 inside now. So h is going to be x is greater than or equal to, because it's a plus inside, we know that the original formula here is x minus h, so it has to be minus a negative to give a positive. So x is greater than or equal to -3, and r is going to be y is greater than or equal to 0. All right, and then now we're getting to some more interesting transformations. So this is a vertical compression, and we're flipping it horizontally. So let's think about what this means for us. So our first point is 0, 0. Well, -0 is still just 0. So 0, 0 is not going to change. So that's going to leave our start point in the same place. Then our next point was 1, 1. And then after then was 4, 2. And then after then was 9, 3. And let's see what happens to these points. So 1, 1 is going to be multiplied by, the output is going to be multiplied by 1/3. So now it's 1, 1/3. And then it's going to be flipped to the other side. So we've got a point down here that is now the transformation. Same thing is going to happen here at 2, 4. So the output was 4. Now it's going to be 4/3, which is about 1 1/3, right? But on top of that, so now it's more of somewhere like, I made a quick mistake. I said that the output was 4. The output is actually 2 at this point. So we're taking 2, multiplying that by 1/3. You get 2/3, which is just under 1. And then you're multiplying that by the negative, right? So my output will actually be somewhere like right here. And then finally, we've got our last number, and that's going to be, our output is originally 9. We multiply it by 1/3, so that's going to be 3. And then 3, I apologize again, I said 9 was the output, but 3 is the output. So 3 times 1/3 gives you 1, and then that would be graphed here. But the other thing is that has happened is it's been turned negative, so it's actually going to be graphed down here. So we see how this is a much more skinny, you could say, graph now. It's been compressed horizontally. And then our last transformation is the 2. So I'm going to now be stretching it vertically. So my first point is still 0, 0. My second point becomes, instead of 1, 1, it becomes 1, 2. Then my third point, 1, 2, 3, 4, up 2, becomes 4, 4. And then it just gets much larger here. So what's interesting about these is that these will not change your domain and range nearly as much. So for this first function, this negative here is what changed my range. So my domain stayed the same, x is greater than or equal to 0, but my range is now y is less than or equal to 0, because now my function is below the x equals 0 line. Then my domain and range for this other transformation, y is going to be greater than or equal to 0 still, and x is still going to be greater than or equal to 0. All right, so let's do a couple of example problems, and then I'll cut you loose. So we have our square root of x plus 1 minus 2, and so let's first shift the function, and then we'll start graphing the points. So from 0, 0, our original point, we're going to shift to the left 1, because up in here we have an h that is a negative 1, so left 1, and then down 2. And then every single point is going to go left 1 and down 2. So our 1, 1 becomes left 1, down 2. Our 4, 2 becomes, well, it goes to the left 1 and down 2. So it becomes 3, 0. And then our 9 becomes 8, 8, 1. So we connect our function here like this, and then we can list some of the points. So some of our new points are negative 1, negative 2. Actually, let's do this as x and y. So this is negative 1, negative 2, and then this is 0, negative 1, and then we have the point 3, 0, and then finally we have our point 8, 1. So my domain is going to be x is greater than or equal to negative 1, and my range is going to be y is greater than or equal to negative 2. All right, and then let's do this next example. So we want to do our transformations in order of operations. So our order of operations is PEMDAS, obviously. So we want to do this transformation first, right, our multiplication, and then do our addition. All right, so let's go ahead and see what this will look like. So our original points on the graph for our parent function are 0, 0, 1, 1, 4, 2, and then 9, 3. Okay, so now let's multiply them by 1/2. So my output for 0, 0 doesn't change. So that's going to be my point for now, and I'm going to go ahead and do these in purple to imply a transition. Then my next point, my output was 1. Now it's going to become negative 1/2. My output for this was, my output for my point at 4 was positive 2. Now it's going to become negative 1. And then my final point, it was 3. It's going to become negative 1/2. Okay, so now I've taken those points and I have transformed them with my first transformation. Now I want to take my purple points and transform those the second time. So they're all going to get shifted up 1. So my final graph will be here. 0, 0 becomes 0, 1, and then this becomes, instead of being negative 1/2, this will be positive 1/2. Instead of being 1, this will be 0, and instead of being negative 3/2, this will become negative 1/2. And we connect our points together, and we have our function. So let's go ahead and list these points. So we have 0, positive 1, and then we have 1, positive 1 over 2. Then I have 4, 0. And then I have 9, negative 1 half. So if we're looking at our domain and range, our domain is going to be still x is greater than or equal to 0, but now my range is going to be y is less than or equal to 1. So we see that our domain and range a lot of the times will be determined by this first point. And that will tell us everything we need to know. All right, so go ahead and start working on your practice problems. If you need any help, let me know. I'll be walking around. Have a wonderful day. Goodbye.